All right, well, hello everybody. My name is Timothy Caine. You guys might recognize me from last year, but I'm also part of the CySER program and have recently graduated from WSU Tri-Cities with my Bachelor of Science in Computer Science. I also was recently offered a position at Caine as a cybersecurity analyst. And last year, me and Kati Panchel, as well as Professor Miller and Professor Della Torre, discussed the early findings of our topic, where we had continued the work of a Purdue graduate student, and we had started doing the SOM and the K-means clustering on the findings that he found. So after Kati graduated from WSU Tri-Cities, this project became my capstone, where me and Professor Della Torre and Miller worked to create a user interface to better search the data. So right now, or before my capstone, all we had was a bunch of Excel files or CSV files with all of our data, all of our findings, and that really doesn't do a lot of good for the industry because it's difficult to search it, right? Sure, you can do a Control F and search through it manually, but that's kind of inefficient. So my capstone, I led a group of 5 other undergraduate students to create a cloud-based web application that would allow users to better search the findings that me and Kati Panchel found last semester, or last year rather. So there are 5 other names, but this is just a reused presentation from my final project. So the main problem with searching through this data set is that it's too big. And this was the same reason why we started this project in the first place. So NVD and MITRE both have hundreds of thousands of CVEs and hundreds of thousands of CWEs, and there's around 3,000 new entries being added every month. This is no longer a problem that humans can tackle. Machine learning has come so far that it's time for us to move into a machine learning aspect for this vulnerability categorization. So the reason that we chose a cloud application was everything's moving to the cloud, right? As we're all interested in cybersecurity, everything is moving to Google Cloud, AWS, even in the industry, everything's moving to AWS mostly. So we chose Google Cloud for this specific user interface because it manages a Kubernetes cluster for you. So for those that don't know, Kubernetes is to put it simply, Kubernetes is a virtual machine manager for you, basically. So you can spin up pods where they do a specific task, and the point of Kubernetes was to create continuous integration and deployment. So if something happens with your pod and it crashes, Kubernetes will automatically spin up a new one for you. So this was useful for our project because continuous integration and deployment is extremely big in the industry, and Google Cloud made it very easy for that to happen. So just a little bit about what we presented on last year and kind of the data flow of everything. We start with the raw data from NVD and MITRE, and that goes through a natural language processing algorithm. That's the VHW-BERT that Professor Miller talked about. After VHW-BERT, it then goes to our SOM map, where it creates our BMUs, which is the best matching unit. And finally, it would go to our K-means algorithm, where it outputs our 138 clusters. So each one of these clusters contains thousands of CVEs, where they have the 2 predicted labels that VHW-BERT gave us, as well as new data relating to the CVE similarities. So NVD and MITRE don't currently give any information on how CVEs relate to each other. So by doing the clustering, every CVE that appears in the cluster is assumed to be similar to the other CVEs that appear in that cluster because they're all grouped together. So finally, it would go to a working KA cluster that is running all the backend algorithms. And finally, it's displayed on a website showing the CVEs, the CWEs, and the SOM map. And for the capstone project, the original goal was that it would update as we get new data. But working in the cloud, you have to pay for every gigabyte of memory that you use, and every minute of processing power that you use is also charged. So with machine learning, most of the training can take, well, on my laptop, I tried to train VTWBERT and it said that it would take 20 days to train. Obviously, it's not going to work on the cloud, and that would cost a couple thousands of dollars, probably a day to run that. So we didn't end up having it run daily or update with new information, but we do have a working proof of concept, which I'll demo here in a little bit. So yeah, these are the tools that we used. All of the pods that were running in our Kubernetes cluster were built using Docker. Docker is also really useful for cloud computing or for cloud development, because each Docker image starts as bare bones as it can possibly get, right? You can have a Linux Docker image that has, it doesn't even have a C compiler. Like, it's as bare bones as possible to keep the memory and the CPU that it takes to compile the image as low as possible. So again, when you're working in the cloud, you have to worry about every gigabyte of memory you use and every minute of processing time. So Docker was a good way to cut a lot of the overhead that it takes to start up clusters. So this is one of the records that we took from NVD. This one is CVE-2021-44228. It's just as an example. We're going to talk about a different one here in a little bit, but NVD provides the textual descriptions of CVEs as well as the severity level, and usually it gives a weakness enumeration, which is kind of what we were hoping to replace with our algorithm. So I think Miller talked about these. So now I'm going to switch over to the website. Okay, but really quick, for my capstone project, all of the back end was done by me, and the front end was done by one of the other members of our team. Her name is Rachel Long. So she's not here, of course, and probably you guys will never meet her, but just so you know, most of the website was created by her. So fortunately, I can't take credit for it. But this is the homepage of our website. It just kind of gives a short description about everything that went into it. The SOM page shows some of the images that I did not see in Miller's presentation, but on the left is a U matrix. So this is a visualization that SOM creates. And if you zoomed in really close, you'd be able to see little data points that SOM plotted. And you can also begin to see the clusters start to form, right? So each one of these bubbles right here is a cluster, or will eventually be a cluster. And this big one up here, as you can see, it wraps to the bottom because we use a toroidal map shape. I think Miller talked about that. So the k-means algorithm is then applied to this U matrix, and we get the image on the right. So the color doesn't really matter here, because the color change is based on the cluster number that was assigned to it. And that's kind of arbitrary, right? The cluster number doesn't really matter. It's the contents that we care about. So don't worry about the color. It's just to differentiate between the different blobs on this map. It also shows the data flow that I was just mentioning, where it goes from NVD to VTWBERT to SOM to k-means. So finally, this is the portion that I contributed for the website. So as I mentioned, we wanted a good way to search through our data set. And currently there was no way to do that, but my capstone project accomplished it using this CVE search. So if we were to use something like 2017-0203, this would be able to display all of the findings that our research produced, where it has the cluster and all the contents. So each of these CVEs is considered to be similar to CWE or CVE 2017-0203. And if you scroll down, you would find it in here. Should have chosen one with a smaller ID. Here it is. So this is the cluster that CVE 2017-0203 belongs to. Each one of the other entries in this list is a CVE that's similar to it. And already the amount of information gain that we get from this is we get 2,559 new CVEs to look at that are considered similar to the one that we input to the website. It also gives the description. This is just straight from NVD, NVD or MITRE. So this is just if you use the diagnostic software, it would just spit out maybe 5 or 10 CVE IDs. You guys have maybe used them before, where it just says, okay, your system has CVE 2017-0203, right? It doesn't give you a whole lot of information. So the idea was that a user or company would be able to go to this website, put in the CVE ID that the diagnostic software gave them, and it would give them the description. It would give the 2 predictions that BTW-BERT created, where in this case it's CWE20 and CWE119. Also has the descriptions for those. And finally, this last box is the cluster data. So I think Jordan showed this as well, but this is the percentage or the purity that the cluster has. So for this specific cluster, I think it was 107. Yes, cluster 107. This was 25.235% 74, 17% 89, and 13% 668. So, and then there are others listed, including 20 and 119, as well as any CWE that was less than 5% of the cluster, we currently just put into other. So even though other is over 5%, it's containing all of the CVEs or the CWEs that are less than 5% of the total cluster. Yeah.
So the 2 main predictions are CWE 20. Those are the ones with the highest percentage.
Yeah. So these percentages were found by looking at the each of the CVEs were assigned the cluster label. So this 2017-0203, it had these 2 predictions, but K-means and SOM placed it in cluster 107. So even though it doesn't have the most pure or the most highest frequency CWEs, it still is considered part of the cluster. And I'll show the raw data with these as well, so you can kind of get an idea of how they fit in the hierarchy that Jordan was talking about. But this was to show additional CWE information that NVD didn't provide. So I have the NVD page for 2017-0203, and this weakness enumeration section is what I was talking about earlier. And NVD provides no information about CWEs that are related to it. So just by these 2 predictions that BTW-BERT gave us, we already have more information about what weakness applies to it. And by looking at the cluster data, we can find, I mean, this is just 8 to 10 new CWEs to look at right here. So finally, I wanted to talk about kind of the hierarchy structure. And we currently don't have a great way of showing the hierarchy yet that Jordan described. We don't have a good way of displaying that on this website, but we can go to NVD and MITRE and manually look at it. So the highest frequency CWE in this cluster was CWE 74, which is the improper neutralization of special elements and output used by downstream components. Injection for all intents and purposes. The second most was 89, which is SQL injection. I think we all know what that is. So 74 had the 707 as its parent, or as the root node in its hierarchy, which is one that Jordan went into a little bit more detail about. And the 2 predicted labels that we found was 20, which is improper input validation, which can lead to something like SQL injection. And the second one is improper restriction of operations within the bounds of the memory buffer. So if you look at how these CVEs relate to each other, and maybe this helps to answer your question a little bit in the back. So CWE 20 is still has 707 as the root node, but it's hard to see how it relates to the two highest in the cluster, like 74 and 89. But CW20 can precede 74. So when you were looking at how an attack happened on your system, you would first see CW20 and then you might see CWE74. So we can already see how it's starting to be grouped together. And 89, sorry, not 89, 119 also can follow 20. So in this case for CVE 2017-0203, it's likely that something like CWE 20 would happen and then 119 would happen after. But it relates to the two highest in the cluster by the can follow relationship that this is MITRE that gives this. So as I mentioned, this is running on the cloud, and you guys can go to this URL. It's highlighted. It's cyberadvisor.cve2cwe.com and use this tool. I have not tested it on scale, so I hope that the 30-some people here don't DDoS the website, but if it does, oh well. But yeah, you guys can search through it. We have support for CVEs from, I believe, 1990 or 1999 to 2020. So if you were to do one after 2020, or I think 2021, you might not get any information on it. But anything in that range from 1999 to 2020 is probably going to be output. So anyway, that's what I worked on. Any other questions?
Yeah, I was going to ask, I guess you kind of addressed it, but I was going to say, is there sort of a way to update this clustering in a live manner to incorporate new CPUs to come out?
Yeah, so
it sounds like
yeah, that's the future work. And I am honestly not super pleased with a website interface for this. I think it'd be much more useful to the industry as an API or something. But this was the topic for the capstone, so I had to deal with what I had, right? But ideally, this would be an API or some type of program maybe where it reaches out to a database that we're supporting and pulls this information down. And all of the natural language processing and the other tools that that Miller and Jordan talked about would be updated as it goes. But just working on the cloud and it being the capstone project, the budget and the amount of time that it took was a big constraint. Yeah.
If you wanted an API but had to build a website, couldn't you just build an API and make the website a front end for it?
Yes, you definitely could. But I just don't see a big use in having a website unless it was using the information that Jordan provided. I still think this has a use. It just isn't great for the scalability of it. So if a team at P&L or something or some other company wanted to use this, a website may not integrate with their system as good as something like an API or a standalone program. But yeah, we could totally keep this as a front end for it.
Yeah.
Any other questions? And just the last thing, Jordan did mention that we can only deal with CVEs at the moment that have already passed through NVD and MITRE and have gotten a description and a CVE ID published with them. But we're working now to use natural language processing on just a description. So instead of putting the ID in the search bar, you could just put the description of your CVE or just, hey, this when I do this on my website, it shows the plain text password or something, right? And you can just put that description in and it would output data similar to this.
You can't tell if CySER's processing or if it's just not returning any similar.
For which ones?
I just randomly grabbed a CVE from Rustlang to see, like, okay, this is something I wouldn't expect to be simple results to, right?
Yeah.
But I'm trying to see, okay, is this thing going to show me that there's no similar results, or am I just going to get a blank output and as if I didn't push the button at all?
Yeah. And which CVE ID did you do that with?
This is 2021-31162. Yeah, that's,
Yeah, okay, 2021, we didn't, when we started on this project, it was in 2020, so we didn't incorporate any of the 2021s. So if you do something before 2021, it'll work. Or it should work.
Yeah.
But please let me know if it doesn't.
here it is, 2018. Yes, the,
Which one is it? 25? It was 2018 dash.
Timothy, you need to validate that the ID is the correct, because if you put in something that is incorrect, no answer. You're gonna get no answer.
Yeah, the search, I will admit, the search bar is kind of finicky because you have to do the identification like perfectly right, or it's not going to give you any output. And yes, maybe this CVE was missed when we worked on it. So it's not perfect. This was just meant to be a proof of concept. And it was a 3-month-long semester project. It's not perfect.
it's also,
You know.
Yeah, this is a proof of concept. So we are just proving that the technology works. Then we can improve that and create something, I don't know, more polished. But for now, it's a proof of
20 CVEs, and most of them are really low priority because they will file a CVE for things that other languages consider not a threat.
Oh, yeah.
Like, we're perfectly okay with this happening in Rust. No, we're not.
So anyway, I think if you just choose a random